All right, in a previous drawing of phylogeny, I showed you the eukarya compared to bacteria and archaea. And I also drew out a little bit more detail of how the eukarya are related to each other. Different groups of eukaryotes are related to each other. But one thing about the eukarya is that the breakup of the eukarya, the divergence into different lineages, happened so anciently that we're still not exactly sure how the different clades of eukaryotes relate to each other, how they diverge from each other. What is the pattern here? So we've got this situation where we don't have goalpost within goalpost. We have kind of like a super goalpost. So rather than looking like a goalpost within a goalpost, it looks like a fork. And what this fork is implying is that we have multiple things diverging at exactly the same moment in evolutionary history. And that's probably not exactly how it happened. So why not? It's kind of like, I'll use kind of an example in reverse. Imagine that there's a car accident. Please imagine that nobody gets hurt in this car accident. That's not necessary for the purposes of this. We're just imagining cars colliding into each other. That is the opposite of divergence. That would be a convergence. Okay? And if you know at least a thing or two about car accidents, you know that typically it's not that they're trying to find somebody who's at fault, who was the first person to collide into the second person. And if persons 3 and 4 collide their cars, they probably didn't collide at the exact same moment, but there was probably an order to things. 1 collides into 2, 3 collides into 4, then cars 3 and 4 maybe collide into cars 1 and 2, something like that. But it's probably not all 4 cars converging on each other at the exact same moment. The same thing happens in evolutionary history with divergence, the way that things come apart from each other. So sometimes we just don't know what the story is, which diverged from which first. And if we don't know, then we can represent that through something called a polytomy. And polytomy means many cuts. So here we're cutting one thing into 4 things. It looks like it's happening just in an instant, but it's almost certainly not doing that. Okay, so our 4 major clades of eukaryotes, and these are probably names that you're not going to have heard before, are Excavata, SAR, which stands for Stramenopiles, Alveolates, and Rhizarians, Archaeplastida, which contains a lot of photosynthetic things with chloroplasts. And it's thought that they picked up chloroplast fairly early on in their evolutionary history, which is why their name means old plastid, archaea, like ancient. And then Uniconta. Uniconta, uni means 1. Conta refers to flagella. So the synapomorphy, the shared derived characteristic of the Uniconta, is having 1 flagellum. And that's something that we'll see in our own, this is our clade here of eukaryotes. We are in the Uniconta. Okay? So if we were to probe down into the Excavata, there are 4, well, for lack of a better word, we're going to call these 4 different phyla. There are 4 different taxa that have diverged from each other. And we don't have a polytomy here. We recognize that there was a divergence that led to 2 subsequent divergences. So our 4 phyla of the Excavata are Diplomonadida, Diplomonadida. Parabasilla, Kinetoplastida, and I'll call it Euglenozoa. Okay, so one thing I would like for you to do, even though you're just probably watching this video somewhere, maybe on your headphones, maybe surrounded by people who are not familiar with these words, is at some point, I would like you to try and say these words out loud with your own personal mouth. So, Diplomonadida, Parabasilla, Kinetoplastida, and Euglenozoa. And you might say, why would I try and make you feel silly like that? The answer is, I don't think it's silly. I think that when people see these words, they look at them and they're like, oh my goodness, this word it's just a jumble of letters that I've never heard before. And often when we see words that we're not familiar with, we don't recognize them, we don't try and take them apart, we don't try to say them. These words have power over us. They retain a sort of mystery, a mystique that is not helpful for our learning. So that's why I say that's part of the reason why I have us do drawing. I think drawing brings familiarity to our learning, and I think that saying words out loud that we've never said before brings some familiarity to our learning, and I think that is helpful. Okay, so we've got Diplomonadida, Parabasilla, Kinetoplastida, and Euglenozoa. All right, so within the Excavata, we've got this phylum called Diplomonadida. And Diplomonadida means double nuclei. And a representative of the Diplomonadida is a parasite known as Giardia lamblia. This is a species name. You should recognize that because I've got capital G Giardia, lowercase l lamblia, two-part name, a binomen. And Giardia lamblia is a parasite that causes a disease called giardiasis. Sometimes people just call it Giardia, referring to the parasite as the name of the disease that it causes. And so we're going to draw kind of a balloon shape, like a helium balloon, and then we're going to put it look a little bit like an owl. And then we're going to put some flagella in pairs we're going to give it 4 pairs of flagella. So bilateral symmetry is a very common thing within this particular phylum. This other thing we've got here, I've got these 2 dots here, and those are our 2 equal sized nuclei that are characteristic of the Diplomonadida. Now, this kind of figure 8 shape here is not a shared nuclear envelope. This represents a sucking disc. And I'll show you what's going on there in a separate view over here in just a moment. And another thing that we're going to have, last thing I'm going to draw on there, is kind of running through the middle of this organism. The structure is called an axostyle, which is a stiffened rod of microtubules. Just to reinforce that, we've got, these are the nuclei, so this is clearly a very small, a microscopic organism. We've got microtubules that we can see forming structures that we can see under the microscope. We've got flagella. So this is meant to be a very small thing. This is not something that you could see. So if you're just out hiking in the woods and you're thirsty and you're just like, I'm so thirsty and I ran out of water. You fill up your jug from a creek and you're like, I'm gonna take a drink. And you're not gonna see this thing swimming around in here. What you're gonna feel is in a couple days, you're gonna have some intestinal troubles. So you might be barfing, you might be having diarrhea, you might be just feeling kind of lousy. All symptoms of Giardia. And I was in the Peace Corps and I got Giardia a number of times, and I've gotten it treated. So it's not something that's likely to take you out, likely to kill you, as long as you get it treated. It's more something that really can reduce your quality of life if you're not able to get it treated, which in a lot of parts of the developing world, that's not an easy thing to do. All right, so this is looking down on the back. This is more of a latitudinal section looking down. So we've got our sucking disc here. And our nuclei are stuck in the cytoplasm. So while this illustration might make it look like Giardia has microscopic owl eyes, that's not really what's going on. You've got this sucking disc, which enables the parasite to, latch onto cells in the liver and parasitize them. And the nuclei are kind of behind that, but because they're translucent, you can see through them using light microscopy. All right, so that is our example of a member of the Diplomonadidae. Many diplomonads are parasitic. There are some that are free living, but they're all heterotrophic. There are no photosynthetic diplomonads. All right, see you next time.